All right. Hello, everyone. So today we're going to be doing instrumental variables for our tutorial. Instrumental variables are a powerful technique, which we'll have learned in class, can allow you to get a causal estimate, even if you don't have panel data, and even if you think that there's omitted variables that you can't control for. What's required is an extra variable called the instrument, which you don't want to include as a control variable in your main regression, but which you can use to basically purge the bad variation from the variable that you think is suffering from kind of correlation with an omitted variable, which we'll have learned this variable is called the endogenous variable, right? So if our treatment variable x1 is endogenous, the instrumental variable can purge that variable of kind of the bad variation, the correlation with the stuff in the error. So let's get to it. We're going to need a new library today. That library is called AER, sorry, a new package, right? So I already have it here, but just remember, if you need to install a new package, you click on the packages tab, you click install, you can search. What you want is this one, AER, and then you'd click install and check mark, or just use this bit of code up here, right? So we're going to need AER, that's new, so let's kind of put that at the bottom, but we'll need our usual stuff as well, tidyverse, lmtest, sandwich, stargazer. All right, so all of our usual suspects. Okay, and now we're going to import the data. So for this coding section, we're going to be using this kind of lecture 8 sample data. So let's go ahead and find where that is. All right, so here it is, lecture 8 demo data. So let's grab that little snippet of code, put that in there, and let's get executing. Okay, so we have our lecture 8 demo data. We have 84 observations of 10 variables. Not a very big data set. So let's make sure that we're using the complete version. Okay, it's exactly the same. So no missing data in any of the observations here. Perfect. Okay. So what we want to do with this data, let's take a look at it. We have P, we have Q, so prices and quantities. And then we have income, population, and CS. CS here stands for cost shifter. So this is an input into the cost. This is an input into the price, but it's the firm's costs. And then we have log P, log Q, log income, log population, log cost shifter. So we have the logged versions of all these variables. So we've kind of just pre-generated using the mutate command, the transformations of the price and quantity variables. Okay, perfect. So started out with an OLS regression. So as the coefficient on a regression that's log for quantity on price is going to be an elasticity. That's typically how we're going to formulate price and quantity regression. And we'll take the log of everything else as well. So when we look at these variables, income, population, I kind of went through them pretty quickly. So income, is some variable. This, perhaps we're at, because this is prices and quantities, this has to be at the market level, right? So each of these rows represents a particular market. And then for income, this is quite a big variation here. So this could be something like aggregate income in the markets. in maybe like tens of thousands. And then we have population. So this could be in, thousands as well, population in the market. So these could be kind of like city-sized markets, right? Perfect. So when we have kind of population and income, these are also good candidates to log anyway, right? Because income is going to be right skewed, population is going to be right skewed. We can plot these variables. I'll leave that. Well, you know what? I'll do it right now. Let's take a look at log income. Rather, let's just take a look at income to see whether or not it's right skewed. So we'll do geom density because we have a continuous variable and we kind of want to plot out where the values. So let's run this, and yeah, this looks kind of right skewed. Most of the mass of the variable is less than 20, but it kind of has a right tail there. And if we do the same thing for population, yeah, so this one is as well as kind of right skewed, and we have this sort of weird hump out near the right. I guess we have some kind of larger markets, some larger cities in there. So here we're just checking that these are right skewed, so appropriate. Okay, very good. Back to our regression. Here's our basic OLS regression. So we run this, and we kind of just look at a simple summary. And we can see that there's a small negative coefficient on log P. It's marginally insignificant, so p-value of 0.06, so just over 0.05. 1% increase in price leads to a negative 0.24% decrease in quantity. Okay. Now there's reasons to believe that price and quantity are co-determined, right? So what does that mean again? It means that price and quantity are determined at the intersection of supply and demand. So with this equation, this is a demand curve, right? Because the coefficient on price should kind of be negative. So what it's saying is that the error in this demand curve is correlated with log P, right? And that makes sense. If there's a positive demand shock, right, that error is going to feed directly into log Q. It's going to shift the demand curve out. That's going to lead to a higher price. So positive demand shock, positive coefficient, or positive effect on price. So there's a positive relationship between log P and the omitted variable, and between the omitted variable and log Q. So there's going to have to be a positive bias on log P. And yeah, what we can see is that even though this log P is negative, it's a lot smaller. It's a lot closer to 0 than we would kind of expect. Kind of expect elasticity numbers bigger than 1, right? Or smaller than -1 rather, most of the time. So we're pretty sure that this is biased because we have, price and quantity being co-determined in a system, leading to this natural feedback effect, this natural endogeneity of P. Very good. So what's our solution? It's the IV regression. Put these up here since that was just kind of data exploration, right? So we have our OLS regression. We have our IV regression. So here's a new command. We'll store this as ivreg1. The command is just ivreg. We have our same log Q, and then we have log income and log pop, as well as actually log P. So everything up until now looks the same, but now we include this vertical pipe, which is just above the enter key on my keyboard. So shift, that key, it's a backslash, but if you do shift, it should be a vertical pipe, right? It's the OR command when we're doing the logical statements. And then what we include are all the exogenous regressors, which include log income and log population, right? We're not worried about those things being correlated with the error. We are worried about log P being correlated with the error, so we don't include it in this set of exogenous regressors. We do include our cost shifter, right? Our cost shifter log CS. This thing we think will affect log P, but is not correlated with the error itself, right? A firm's costs should not be correlated with the demand shock, right? The costs are something internal to the firm. So we run this. Let's take a look. Very good. Strongly negative coefficient on price. It's now negative 3.13. So our elasticity says 1% increase in price leads to a 3.13% decrease in quantity. Okay. Now we need to do this with heteroscedastic errors. That's fine. We do it in exactly the same way as usual. You can see that the t value has gone down a little bit. So the p-value has gone up a little bit, but we're still very safely significant at the 1% level. Okay, perfect. So we can present these things side by side. So to do that, we want to put them in Stargazer. We want to store our robust standard errors. So we'll do robust standard error for regression 1. That's the square root of the diagonal of variance covariance matrix of rank 1. And we have the same for our IV regression. And we'll put them side by side in Stargazer. So we can gaze at just how great our improvement in the estimation was, right? And there it is, right? So OLS is our methodology here. Instrumental variable is our methodology here. We see that the change in coefficient on log P is massive, right? The change in the coefficients on other things are quite large as well, kind of suggesting that these things are all correlated with each other because they're all being affected by the introduction of the instrument. Okay, so that's pretty much it. That's how you run an IV regression. Of course, we might want to check that the instrument is relevant. How do we do that? We'll do our first stage regression, and that is just a regular linear model, right? But here we're basically regressing log P, our endogenous variable, on all of the exogenous variables. And we're going to want to check using a t-test that the t-value squared on our exogenous shifter on our instrument log CS is larger than 10. Right, and what we can see is that it is 2.9557, right? Which is actually not larger than 10 if we square it. It's less than 10, right? So actually our instrument, it's relevant, it seems to help, but it's not strong enough for us to be confident in the standard errors that we're getting on our IV regression. Okay, so in this case, what's going on is, like, what should we conclude? Should we conclude that there is no effective price on quantity? So I believe it was Harun God that I was talking about this in class with. We have a very strong prior that price does have a negative effect on quantity. We have a strong prior belief. If we really think that our data is going against that fundamental relationship for the demand curve, that's fine. We should just have very, very strong proof. And this is not strong proof. This is kind of a marginal, we marginally fail to reject that our log CS instrument is relevant enough, right? It feels like with only 84 variables, maybe what we could do is try to gather more data, right? But with the data we have, the instrument is not relevant. The way that we would answer this question on an assignment or on a test is instrument's not relevant. We can't say that our IV is doing a good enough job in kind of dealing with the endogeneity, okay? So that's it for this week. That's pretty much all we need to do. So yeah, it's a great technique. If you have a co-determined system, we'll have kind of talked about this in class, but you have something like demand and supply, you have some instruments baked into the system, right? Things that affect supply but not demand will be a good instrument, right? So if you have that system in mind, then you can find an instrument. If you don't have that system in mind, if the endogeneity is coming from some other source, it can often be quite hard to find an instrument. So I don't expect that you guys will be able to sort of find an instrument if you're doing your group project. And in general, finding these things can be quite hard. But this is definitely something to keep in mind for the demand curve situation, where it's extremely relevant and it should be fairly straightforward to find a cost shifter, especially if you're working for a firm and you can observe their balance sheet and their costs. Perfect. So that's it for Ivy. I will see you guys in class.